Thanks a lot, guys. Basically, the things that I want to walk through today is just understanding a little bit about open source software and sort of developing sort of a framework for the different dimensions for it, how it affects the development of data systems, understanding whether or not open source, is just a term or whether or not it provides clinical opportunities. So areas for open source within the clinical context, strategies and decision points for understanding open source software. I have a few slides sort of at the end to discuss open source in the context of our current NLM grant with CHLA and JPL. I'm not going to go into too much detail on it because Dan covered a lot of it, and Andrew Hart will be covering it in a lot of detail tomorrow. So this is a shorter version of a half-day breakout talk that I gave at the NASA Earth Science Data System Working Group meetings, and so there's a link to that talk there in October 2010, and then I actually gave a presentation at the NASA Open Source Summit. This will look eerily familiar with that, and there's a link to it there. So that's me and my son having fun in Hawaii. And I am an architect and development lead at JPL in Pasadena. I'm a software architecture and engineering professor at the University of Southern California. I teach classes in software architecture and search engines and information retrieval. I'm also a member of the Apache open source community. I'm the VP of Apache OODT, which you guys have heard a little bit about today. I'm involved in the Tika project. I'm the VP of it at Apache, and then I'm also involved in Nutch, which was the original. I heard Hadoop mentioned earlier. Hadoop was actually spun out of Nutch, which is an open source search engine project, and then various other projects at Apache where I'm a mentor and someone who helps out in the Apache incubator. So let's talk a little bit about open source software. It's here. Chances if you're building software nowadays, you're using some type of open source software. You're either using it and consuming it in your application, or you're designing your software system so that you eventually intend to distribute it to someone downstream, perhaps in an open source fashion. So let me give you some context. This is a diagram maybe representing kind of a prototypical clinical situation in the upper left hand portion. Let me just make sure that's the upper left. Okay, good. It's the same on the screen as it is here. It's a good thing. So in the upper left portion here, we have various sort of data sources that are being collected about our little sick patient person down there. In the bottom part of the diagram, we have things like historical records that have been collected long-term, things like monitor data, blood pressure, heart rates, things that are connected, various machines taking sort of near real-time or real-time data. Doctor and nurses' notes, which I heard mentioned earlier, and I heard mentioned as being difficult to understand. Yes, it is. It's because it's free text and various other mechanisms for that. And then other sort of offline research databases. And in this particular clinical example, we have the notion of taking and extracting data from these data sources and putting it into some type of file system. There's a lot of reasons that could happen. It could happen because perhaps those data sources are the gold sources there on the left, and they don't want people like us that are doing research touching them. Or touching them sort of actively. So they might allow us to get a snapshot of the data one time, pull it into our sort of non-secure, scary area, and then do research on it. So that's what you see there sort of in the middle on this big data file system. And we might take the files that we extract information from these various data sources, and we might combine them somehow into various sort of research databases downstream from that. We might combine various records that we've extracted about patients regarding blood pressure or heart rate. We might combine various records that we've extracted about mortality and then analyze them in different ways. Scientists downstream of those combined databases might write papers about that data. They might pump the data into things like MATLAB or R or various other tools and do analysis on it, which may feed into papers themselves. And then we may share the data with other hospitals using various secure methods of sharing it and making sure that it has the sort of appropriate methodologies for that. So where in this context is open source software most useful? That might be a question we might ask ourselves. We might also ask ourselves what area in this is a good sort of representative example for producing something that might be reusable in an open source context sort of downstream of us for other people who build the same type of system over and over and over again. So there's a bunch of concerns with respect to that, various dimensions and parameters that are important. The first one that, nearly everyone, when they think of open source software, they think of licensing. And you hear about things like the GPL and V2 of it and V3 and the LGPL, the Lesser GNU public license and its various versions, the BSD license, the MIT license, the Apache license. Your own custom license, which we typically call in the open source community a vanity license, which various organizations produce that aren't necessarily approved by the open source commission like that. NLM might have a license. CHLA might have its own open source license. JPL and Caltech certainly do. I won't even bother complaining about it here. There's the notion of copyleft versus copyright and the distinction between them with respect to licensees. I'm not going to get into a lot of detail on that, but just sort of a high-level perspective. Copyleft licensees for open source software is sort of a play on words with respect to forwarding or passing along certain restrictions in upstream dependencies for your software. So the classic example that I use to illustrate copyleft versus copyright in terms of open source software licensing is I might have made a piece of software at some point when I was a grad student, and I might decide to make that software available and disseminate it and let people reuse it in their application. I might have picked a copyleft license. Well, to license my software and then distribute it to folks downstream. Examples of copyleft licenses are things like the GPL or the LGPL. Those licenses give me permission to put into that license that you, as a downstream consumer, have to make sure that your source code is not sort of hold off. You can't build proprietary software. You have to make it so that your software, you share your source code with everyone else in all downstream applications. So in doing that, I've sort of infected or passed along kind of like a disease, which is funny sort of in the clinical context, but with respect to that. Your software as a downstream consumer now has to take those constraints that I've pushed sort of upstream of you. That's sort of the notion of copyleft licensees. Copyright type of licensees don't impose those types of restrictions. They're a little bit more open with respect to that in the area of redistribution, which is one of the other sort of concerns that we're sort of talking about. Other things that you care about when you think about open source software is the type of community, and I'll get into detail on all of these sort of issues. I'm just sort of sketching the landscape right now. But there are various sort of community styles for open source software. The famous sort of help desk syndrome, where you don't ever really expect anyone from the outside world to really modify your software. You control it. They might file bug reports, tell you what's wrong with it, but your team in the end fixes it, versus sort of a community style where you expect people to get involved and actually pick up a shovel and help dig the hole. Other concerns in the open source world, things like intellectual property. That's a really big thing. Who owns it? How does that open source software that you're using in your sort of mission critical application affect your intellectual property? Open source ecosystems. There's a lot of different places out there to get open source software. Which is the best one? Which one should you be putting your software out into and disseminating it? There are issues with contribution. When folks here at CHLA contribute to an open source project, are they allowed to do it on company time? Same goes at JPL. Are they allowed to do it? What's the policy? What's the governance for that? How does that impact sort of the development of software? Responsiveness is another thing you have to be concerned with when you deal with open source software. How responsive is the open source community? Did you send them an email saying that you have a bug or you experienced a bug in the software and it took them a month to get back to you? Did they respond the next day? How did they respond? How do you get sort of help and guidance for picking out whether or not the open source community is actually alive, or it's something like, for instance, the project I started, in a random drunken night, Christmas, about 7 years ago, that I haven't touched in about 7 years, and it's sitting out there on SourceForge. How do you find that out? How do you interact with sort of open source projects? How do you implement them? What are the different strategies? What are the legal strategies for that? So these are some of the concerns that you have to be sort of thinking about when you're dealing with open source software, even in the clinical context. And the answer is all of these concerns are sort of cross-cutting across the entire sort of enterprise there. In fact, they come up in the databases upstream that collect the information from the patients. There are license issues with that. You have to be concerned with how that sort of impacts your downstream components as well. You have to figure out in those research databases, as far as software, there's a lot of opportunity for for reusability there. How does that impact, where you put that software? It's cross-cutting across sort of the entire enterprise. So let's dive into licensing a little bit. There's tons of approved sort of open source licensees that are out there. How do you sort of distinguish between them, and why does it matter? The differences mainly have to do with sort of three areas. Commercialization, redistribution, and attribution. Commercialization from the perspective of that sort of example that I gave you earlier. If I'm licensing, or if I'm putting an open source software component out there and it's a copyleft license, it's going to be harder for you to make a commercial product downstream of that. Because I may have put into that particular upstream component restriction or a clause in there that says, you know what, everyone else who uses this component in their application downstream of me, you have to open up your source code to them. It doesn't matter. You can't sort of black box it. You can't build a product. You can't build something that hides that from somebody. as opposed to other licensees, which have sort of no restrictions based on that. And then beyond that, you get into areas with respect to redistribution. You get into areas like software patents, which we'll talk about sort of in a little bit later on. But one of the areas that you have to be concerned with respect to that in licensing is what a little thing that they call patent termination, in which it's pretty much the main difference between licensees that are copyright but that aren't the Apache license. So for instance, the BSD and the MIT license are very open. They're copyright licensees. They have very little restriction for things like redistribution, intellectual property, contributing and stuff downstream. The one distinction that they have between, for instance, BSD and MIT and the Apache license is that BSD and MIT don't include something called the patent termination clause. So let's take the example real quick. I made a piece of software here at CHLA. We're building it as part of our data system work that we're dealing with. Someone downstream, we put it out into the open source community. We license it under the BSD license. Someone downstream of us in the next NLM grant or some sort of person in the community wants to pick up our software and reuse it. Randall told us to file a patent on it at the same time that we, licensed it under the BSD clause or under the BSD license. There's nothing that prevents us from doing that. And then 10 years later, we're a little cash hungry here, and we decide to file on that patent. And then basically anyone downstream of us that had used that component, thinking, oh great, it's open source, it's licensed under the BSD, they're not protected if we go after them, basically, and we try and sue them basically for some type of we try and file on the patent basically. If we had licensed the component under the Apache software license when we did that, and the person downstream of us consumed our particular application or component that we built at CHLA, and Randall and I decide, we get a little sort of money hungry, 10 years down the road, we do the same thing. There's a clause in the Apache software license called patent termination, which means any upstream patents are basically dissolved and downstream consumers of the software. So these are types of issues that you have to sort of be concerned with when you deal with licensing. The other main one is sort of attribution. These can sort of arise in various forms as to whether or not you have to attribute the code in your code, whether you need to include things like notice files, and various other sort of aspects with respect to that. So you've built some sort of awesome piece of clinical software, and then you wonder, sort of beyond licensing, what are your options for distributing it to other PICUs, other grant-funded projects and collaborators? The answer to that, to the question as to what license you're going to choose in that situation is hopefully one that supports redistribution, like I was just talking about. But then the question is, if you're going to redistribute it, how do you redistribute it? Redistributing software requires infrastructure. Right? You have to have some type of Subversion repository. You've got to have some type of GitHub or Git type of system, configuration management system. Who's going to set it up? These are very real concerns when you deal with open source software. And there's a number of services and ecosystems that live out there with respect to that. Should your organization use one of these ecosystems? What are sort of the advantages or trades between that? Should they stand up their own? Should you just set up your own configuration management repository, put your code in there, share it with other people by maintaining access to it, things like that? Where should you go? And if you go to one of these places, if you go to SourceForge, Apache, Eclipse, Google Code, to go share your code with another project, what are the implications of that? Some of these ecosystems and these places have different maturity models. They have different ways and governance models of doing things. Some of them have none. SourceForge, for instance, I'll illustrate an example in a couple slides, the difference between it and, for example, the Apache organization. Apache has a maturity model and a governance model for dealing with software. If you go and you put software there, it starts out sort of on the left-hand side of that diagram with an incubation period. You make a proposal, basically identifying it, what you're going to build, how you're going to build community, how you're going to build diversity between organizations so that no one organization is solely responsible for the maintenance of the open source software. If your proposal is accepted, at your point, you become a podling, an incubator podling in Apache, and it's your responsibility at that time to sort of fulfill the things you said in your proposal that you do, to make software releases, to gain interest, to diversify, in effect. And then at some point, the project might be ready to graduate, and it has two options to graduate into sort of an official Apache project at that point. It can graduate into a top-level project, which is wholly encouraged. Apache, I think, has probably 90-plus top-level projects right now, so it's not a whole bunch, but it's also not sort of a small amount. Or you can graduate to a sub-project of an existing TLP. And increasingly, these are sort of discouraged because it encourages sort of umbrella syndrome with respect to sort of management of the project. So Apache has an organization. It's a meritocracy. Basically, as an open source contributor to it in terms of software, you earn and keep your credentials. You start out as someone who's submitting patches. You don't have any commit access. You don't have the ability to modify the code. You're reliant on the actual people that have that access to take your patches and add them. At some point, you become a committer. You get access to commit to the code, to evolve it, to change it. Eventually, committers become PMC members. They have binding votes on releases of the software and the addition of new personnel. At some point, you might become a chair of an existing committee or project management committee. It's your responsibility at that point to basically file reports. You get the glory of being the person who files reports to the board. An ASF member has a binding vote on the state of the foundation. They elect the board of directors, and then eventually you can become a director, sort of chairing the oversight of the foundation, the projects, and being involved in that. So let's contrast that with SourceForge. If you're thinking about different sort of open source ecosystems and communities out there, SourceForge is a different model. It's, basically, you have a project proposal. You can type 10 lines in an email. Your project's accepted. Let's get going. And you have a full-fledged sort of SourceForge.net project at that point. You have your own Subversion access or CVS access, configuration management, mailing lists, a wiki. And it's your job at that point to provide oversight to it. So these types of communities with sort of little governance and the ability to select many different open source licensees require sort of a lot more maturity when you're managing the project and when you're going about sort of evolving it. It's really up to you. And if you're like me and you started that project 7 years ago and you haven't looked at it since, it's still there, but it's dead, basically. Nothing's going on. There's no sort of foundation-wide rules or guidelines for committership or project management, no guidelines for sort of measuring the health or responsiveness of the project to ensure that it's sort of continuously, it's actually doing something. So there's a ton of sort of other concerns with respect to open source ecosystems. I'm not going to go into the details of that now. The big elephant in the room is what's the exposure, right? Some of these people know off the top of their head when you think open source software, that's the place to go get it. Some of them they've never heard of. So, you know, that's an important sort of consideration when you're thinking about where to put your software, where to put it into open source, and where to share it. How do you want to have your project sort of run in the open? If you go ahead and decide, you know, if Randall decides he wants to put all of his CHLA code at Apache or at Google Code, what does he do there? Well, he's got two choices, effectively, for different community models to run his project. The first one is basically you're kind of in the vendor model. You're in the sort of help desk model. You expect people to come and tell you what's wrong with releases of the software, to file bugs, to give you some sort of insight, and then your team are people really that are responsible. They're only people that are ever going to have commit access to it, have the ability to change the code, to respond to that, and to make releases. That's sort of a help desk model. It's encouraged by particular communities like SourceForge and Google Code. A lot of projects that are in this sort of help desk model sort of are stood up there. They also call it sort of a bit drop model. The other major sort of model for open source software is community-based. And in that model, basically, you're expecting the contributors to your software to not just tell you what's wrong with it, but to actually do something to fix it, to submit a patch, to file, you know, some documentation to help sort of evolve the code. And eventually, based on that, if it's a meritocracy, to gain access to become one of those people that can evolve the software and take care of that. And the Apache Software Foundation, the Eclipse Foundation, all of the foundations sort of follow that model and support that type of community model. Let me go ahead and skip this. Let's discuss a little bit about sort of intellectual property. One of the biggest things with respect to intellectual property that you can deal with when you're thinking about sort of open source software is just understanding different ways to sort of package open source software components and then further distribute it. And understanding things like trademarks and things. So CHLA might have the Children's Hospital, Los Angeles, Virtual Pediatric Intensive Care Units, FUBAR software powered by Apache Hadoop. Right, which is one way to describe some product that we're making that's powered by the Apache Hadoop technology that deals with data systems. So you could have Seattle Children's Hospital's BAS built on Apache Pivot powered by Linux, right? And understanding the meaning and the ways that you actually have to brand particular components in software that you're dealing with respect to open source software. So one example is how do you understand trademarks? How do you understand existing open source software components and the implications that has on the software that you're developing? One example is NASA. They basically protect their marks through the new technology process that we have there, which is a way for people to file on new inventions and new technologies during which legal teams basically uncover marks. They uncover potential patents. They help select licensees sort of as appropriate. Basically, the answer to who owns it and sort of with respect to intellectual property in open source software, the answer is still basically the center that developed it or the project that started the development, but you need to sort of be wary and understand various rules when you're picking open source software components and including it in your product. There are various sort of ways to contribute to open source software. I've touched on a little bit of them so far. They're basically built around contributions. They can be writing documentation, sending mails to mailing lists, volunteering to make releases, positively contributing towards the evolution of the project through discussion. What did I leave out? Well, I left out code. That's certainly one way to contribute, but it's not sort of the only way. And various methods of code contribution bring you back to various community methods, the help desk model versus sort of the community one, understanding how you want to accept code, accept patches. These are all things that you have to be sort of concerned with when you're dealing with open source software. Responsiveness, the biggest sort of takeaway from this slide is responsiveness is probably the biggest sort of metric I think that we have nowadays for measuring the health of a community. Does your patch diff, does your mailing list questions go unanswered? These are ways to sort of understand, basically, if you want to be part of that open source software committee or using it or not. There are various mechanisms and methodologies for getting help with open source software. There was a common belief for many years that if you're using open source, it's not as good as using some type of vendor, some type of proprietary software because you have support, you can pay for it, and so forth. That's not true. Nowadays, there are plenty of companies that are being stood up around open source technologies to provide you support in sort of the same vein and fashion, training along those lines. I'm going to go ahead and skip this. I'm going to skip this because I know I'm down on time. Basically, takeaway in terms of interacting with open source, mailing list interaction is very important. I kind of touched on that a little bit. Architecture and implementation issues. The biggest thing I could point out is to hopefully pay attention to Andrew Hart's talk tomorrow. He'll talk about a little bit of that. Leveraging active technologies is something that's important. So don't be expecting, for instance, if you're going to the Haskell community, which is a programming language that hasn't been leveraged very much beyond sort of a core set of 10 people across the world for many years, and expect it to sort of respond to you the next day, or understand how applicable or useful it is in your particular situation. So just understanding what the difference between active is. I touched a little bit on legal issues. I'm going to kind of skip through some of these. I'm going to skip through that. One of the things that we've been doing, Dan kind of touched on this, is that we've been sort of working through this process and developing this framework in our work on the Apache ODT project over the past 10 years, and specifically over the past 5 years, and trying to bring it to Apache, and just understand the different implications of that, how it can help us in terms of working with other groups. It was one of the sort of, I'll call it catalysts for being able to get started on our NLM project with Children's Hospital so quickly, and being able to get folks here at CHLA and folks at JPL working together and working on software and not having to deal with a lot of these issues, these new technology things, these software patent, these IP issues up front, because we had already worked out a framework to deal with that. And it's sort of the basis of our joint CHLA JPL NLM project data management system. It's got a number of architectural principles that all support sort of open source software. I'm not going to have time to go into any of these details. It's got various components as well. I'm also not going to have time to go into that. One thing I will mention is that you find this a lot, I think, in open source software, is that there's typically some type of core framework or base in an open source software component, and then there's a process effectively as you deploy it to various projects, as you deploy it to various missions, where adaptations to that base occur, and then there has to be a way to get those adaptations back in, hopefully. And we have a process that's very similar to a lot of open source communities for bringing those contributions back in. I'm going to go ahead and skip that and just basically wrap up. If I had to sort of nail down the couple takeaways from this, the biggest thing is open source and understanding it as a strategy to your organization is critical. Basically, one of the things that we're seeing a lot is a desire by a lot of the funding agencies to understand how you can sustain software beyond the life of a grant. Open source is a great way to do that. Putting it out into an open source community where there's no single point of failure and where there are many organizations contributing to it is very important with respect to that. All licensees, communities, and development practices in open source aren't created equal. Understand them. It's important. And our work on ODT so far, even though I didn't really get a lot of time to touch on this, it has allowed sort of great progress in our collaboration based on sort of understanding the framework for open source software that we've developed as such. And I'll shut up now. So thanks.
How are we doing time-wise?
I think I finished right on time.
You made it.